Hello there. Alright, so if you watched any other project videos in this channel, you probably noticed that all of them have, in some sense, included Pikachu in them. We built a Pikachu command line program, we built a Pikachu text-based user interface, and even a Pikachu graphical user interface. So now that we're building a game, it almost feels like it's all sort of been leading up to this, right? The Pikachu game. And if you thought so, you'd be correct. Because today, we will be recreating the famous game featuring our beloved Pikachu. Today, we'll be making in Rust the one and only Pikachu Volleyball. To build this game, we'll be using the Amethyst game engine and the ECS pattern, which is short for Entity Component System. So to give a brief introduction of ECS before we get into it, first we have entities. Entities are just objects in the game, like a player, an enemy, or obstacles. Now, say that, for example, a player can get hit by an enemy and have its health points decreased or something like that. Now, adding on to that, a player can escape enemy attacks by moving, dodging, or even attacking the enemy. Now, on a high level, how would you go about coding this? Well, for one, you could create, say, a player.rs file and implement your collision, attack, movement, or transform mechanics all in there. But, as you can probably guess, that becomes pretty easily unmanageable. So, we break each of these aspects onto individual components and attach them to entities, making our entities really just collections of components. So, for example, your player and enemy, they could be movement, attack, and collision components, while your obstacles can just be collision components. And lastly, so we covered entities, we covered components. Lastly, we have the system. The system is what updates each component. So for example, when there's keyboard input, update the movement/transform property. When there's a player-enemy collision, damage the player, and so on. Anyway, you get the gist of it. ECS allows us to structure our architecture and makes it possible to build more complicated games. To spare us the trouble of loading screens, I've already started our project using Cargo New Pikachu Volleyball and opened it in VS Code. In some other tutorials you find online, you may see people creating their Amethyst projects with Amethyst New, so Amethyst New instead of Cargo New. And that was an option, or is an option, but developers are no longer maintaining that tool set. So I don't know, I figured it'd just be better to continue with the good old Cargo New way. Anyway, to write Amethyst code, if you are on Linux, you have to install a few system dependencies. I'm using a Linux distribution based on Ubuntu called Pop! OS. So to install them, I simply had to do this. Now I already installed them, so I won't go through it again, but this will get us all that we need in terms of sound, font rendering, XML parsing, and cryptography. As far as I know, if you are on Windows or OS X, you don't have to install any system dependencies whatsoever. But regardless, I'll leave a link in the description where you can read more about setup and all that fun stuff. Anyway, for your convenience, all the system dependencies installation commands that just listed here will be in the description. Alright, one last step for Linux users is to install a few other dependencies, funny enough, which is for our rendering backend. So I'll copy and paste this, and you see that we're installing libvulkan dev, Vulkan, and Vulkan. So all Vulkan stuff for rendering backend. Again, will be in the description. Now back to the steps that applies to all viewers. Let's go to our cargo toml and list Amethyst as a dependency to our project. So I've opened up Amethyst on Craze.io, and we can see that the last version is 0.15.3. So let's come right here, and we'll say Amethyst. We'll say version equals 0.15.3. And one more thing we'll add is features, and we'll say Vulkan. Save that, and with that done, let's get the sort of boilerplate code, which is pretty much what that Amethyst new that I mentioned before did for us anyway. So I have it on my second monitor. Let me just copy it, and let's replace our entire main with that. Right. So, before I sort of walk through what we just did, there is one more thing we have to set up, which is a folder called config. So go to our root folder, we'll create something called config, and inside it we'll create a file called display.run. A .run extension indicates that this is a Rusty object notation, which is really just a data serialization format that looks similar to Rust syntax. So inside this file, we'll add this. So title to our game and dimensions. Great, now we are done. If we just run cargo run, it will take a bit. So I will be right back. All right, we finally finished running. So cargo run should yield this. If it didn't, perhaps I can help you out. Because other than my machine, I also ran this code on a Windows device and an OS X device. So if you're on Linux and couldn't get the app to run, it's probably because of your Rust version. So let's close this. Coming to your terminal, if you just close this so you can actually see, and maybe move my camera up. There we go. Sorry about that. Alright, so just running Rust up default 1.47.0 fixed all my issues. Again, this is if you're on Linux. Now, if you are on Mac, all my issues were fixed by simply installing or updating Xcode and its command line tools, and replacing Vulkan by Metal. Okay, in our features in our cargo toml. On Windows, I really didn't encounter any issues whatsoever with Rust version or features, and it just ran perfectly out of the box. So I can't maybe really help you there. But anyway, troubleshooting aside, let's walk through what just happened here. And by that, I mean let's just go through the boilerplate code that we just copy and pasted. So first of all, nothing to really unravel here, is just a bunch of imports. So if you're following along, pause the video right here and copy them, I guess. And next up, I want to jump to the last two lines before main's return. These two. So we are initializing an application, so application new, and then we are running this application. Our application is, of course, the game. This pattern is pretty similar to what we did in the last video with the graphical user interface. So if you remember that, good. But you don't really need to remember to follow along. So yeah, initializing application and then running it. Alright, so this application takes three parameters. It takes the assets directory, it takes the stage, and it takes the game data. So let's go through them one by one. The assets directory is just where we keep like sound files, images, and whatnot. And we're getting it by a relative path. So you see right here, we get our app root. This is just our application root directory, which will be like right here. And then we're getting the assets folder off of it. We'll be creating this assets folder later on, so if you don't understand where it is now, you'll understand later. And next up, we have the state, this Pikachu volleyball, which we are creating in here. So this is a struct Pikachu volleyball, and we're implementing simple state, the simple state trait to Pikachu volleyball. If you don't understand what a state is, to give an idea, it can be things like loading, main menu, gameplay, pause, result, and so on. So it's literally just the game states. Yeah, and then the third parameter that we need is the game data. I keep butting my face in front of the code. Anyway, just to show you what I meant, game data is this. Okay, so that's how it looks like. Initial state, Pikachu volleyball, and then game data, just in case you're following along and copying. There you go. Now the game data sort of just tells the game engine to load all that we need. And this all that we need is separated into bundles that are assembled by this game data builder. Okay, so for example, we have the transform bundle. The transform bundle is what will register the transform components and transform system so that we can start moving game entities around. Next, we have the rendering bundle, which is sort of a special bundle because it allows us to mix in plugins and get the bundle that we really want. So you see that we have here these two plugins. So for example, say render to window. Render to window is what's creating our window in accordance to that display.ron file. And it's getting it from the config display path, which we're also getting from a relative path off of the config directory. Oh, actually, I was talking about assets before. So the app root is this, and then we have the config file, and then we have the display.ron inside. Right. On top of that, we are setting the window color and opacity with this width clear. So these are RGB values. So R is 0, G is 0, B is 0. That's a black color, and then we're setting 1 for opacity, so completely opaque. Alright, next up we have the render flat 2D. This is what we need to make our 2D environment work. And we get a bonus sprite sheet processor out of it, which allows us to draw 2D objects from a sort of big texture picture. We'll get into that later on. Anyway, other than this, the only line that we didn't cover, I think, is the first one in main, which is this Amethyst start logger. So this logger is just what we use to see errors, warnings, and debug messages. So if you're curious, try removing it and try running the project again, and you'll note that you can no longer see those nice little info messages that we saw before. Alright, so first of all, let's organize our code a bit by moving our game state outside to a Pikachu volleyball.rs file. So we'll create a new file, Pikachu volleyball.rs, and we will get our game state and move it right here. Now, of course, we'll have to reference that in here, so we can just say mod Pikachu volleyball, and then use crate Pikachu volleyball, Pikachu volleyball. Okay, so this is crate. Remember absolute path. I made a video on it. Then Pikachu volleyball is the name of our file, and Pikachu volleyball is what we're getting off of here. So this. Okay, and mod is just sort of creating. Right. Of course, this won't work by itself. You see that we're already getting an error off of simple state. So let's bring in the imports that we need. Good. Now we see that we don't have that simple state error again anymore. Now let's, I want to create two constants for our arena height and width. Those will be 1,280, sorry, 1,280, there we go. Now looking at our import statements, you see that we are getting a camera. In video games, we use the concept of a camera to determine what will display on screen and how. So on top of our pub_struct Pikachu volleyball, let's initialize our camera. And we'll do that with this function. I'm copy and pasting things just sort of to speed up the process. I'm predicting that this will be a long video, so I'm trying to make it as concise as I can. Yeah, so we created this arena and we'll be using it inside of the camera, as you'll see in just a second. So for now, let's talk about this entity that we are creating. First, we're creating it on the world, which is a parameter to our function. And we're making that entity our camera with the first width. Okay? This right here. Let me close this so we can see the full camera. Full camera, the full ID. With this first width. See, so we're using the arena width and arena height. Right. Now, remember how I said before that the camera sets what we see and how? This is the what, right? We're configuring it to cover the area set by the arena dimensions. In the next width, we're using this transform that we created right here to set up the how our camera will see things. That is, we move our camera to the middle of the arena and up by one dimensional unit. So to help us visualize the setup a bit better, here's a great image from Xing Liu's book. So let me bring it up. I have it. My downloads, reference image. Right. Oof, that's sort of pixelated, but hopefully you can see it. This is the camera. Arena height divided by 2, arena width divided by 2, and 1 sort of out of the picture. Right. No more pixelated images. So now that we created the function to initialize our camera, what should we call it? Or more specifically, at what state should we call it? Should it be on start, stop, pause, resume? To me, it makes sense to initialize it on our start state. So let's get on that. Inside our simple state implement that we have right here, we will add the following. Now, in here, you'll notice that the world is really just a sort of holder for resources, where resources are the data that is needed across the game, but not one specific entity. Now, there's really no point to cargo running again, because it will still be the same. But actually, I noticed one problem. In here, this should be world with an uppercase W. That's because we're using the one that we imported from Amethyst. Right. So yeah, as I was saying, there's not much point to cargo running, so let's move on. Alright, now let's go to PikachuVolleyball.rs and add a player component to it. We can do so by saying this. And before we look into it, let's add this import as well, which I conveniently already put. So if you're copying, don't forget to paste in ACS or write down ACS prelude component, then select storage. Okay. Right, just notice I forgot a semicolon here. And okay, so we are creating a player struct which has three properties. Side, which is an enum of left and right, where we're deriving these two, partial EQ and EQ, and width and height. So side is where the player is in comparison to the net, right? So you can be to the left side of the net in volleyball, and you can be to the right side of the net in volleyball. And the last two are pretty self-explanatory, width and height, which is where we're using these, where we will be using these two constants that we just created. Height. We then implement a new function for player, which just, well, does what any other new function would do. It just creates an instance of that component. Now, the last couple of lines here, they're pretty much just telling Amethyst that player is a component, therefore making it possible to attach it to entities. Now, it might be a bit confusing why player is a component in the first place and not an entity, like I mentioned in the beginning of the video. So to understand it better, let's just look back at when we created the camera entity. Scrolling up, we see that to create the camera, all we said was world create entity. That's it, okay? We then attach a camera component which categorizes our entity as our camera, okay? So remember, entities are just a collection of components. Anyway, that aside, one final detail I'd like to add is that this dense vect storage can look intimidating, but it really isn't. All it is just specifying how our data, like side, width, and height, are stored. So in this case, dense indicates that they are stored in a vector with no empty indices. So it will be side, width, height, where it's 0, 1, 2, nothing into it. Okay, now let's finally add them to our world by creating a new function called initialize players, where we'll also pass the world as a parameter. So we can just put it right below our component for player, or component implementation for player. And as usual, let's walk through it. Okay, so first of all, you can see that our newly created entities have these two have two components. They have player, which, as I said, defines them as players, and we have transform, which again is just as our camera, right? We have transform here as well, and is just these two transforms, left and right. And for the transforms, we're setting them up. Again, let me close this. We're setting them up in here. So we set the translation Y to be 1 at the left, of course using the player width as sort of the starting point, because we don't want to cut the sprite in the middle. And then the other one will be arena width minus half the player, right? Because we start looking at the player from the middle. So if you're looking at myself as a sprite, you'll count my coordinates from the middle of my body. So if you put me at arena width, you'll be cutting me in the middle, right? Because this is my pivot, I guess. Okay, so we did that, and now the last thing that we are doing is, in this line, is we're just flipping one of the sprites that we'll use. Now, of course, we haven't gotten the sprites yet, but as you'll see in just a bit, we'll be using the same sprite for both Pikachus, and in the sprite, Pikachu is facing left. So for the right one, we have to flip it so that it's facing, wait, no, sorry, it's facing right. So in the other one, we have to flip it so that it's facing left. Kind of confusing to speak to the camera and point in different directions, but you get it, hopefully. All right, so that said, we'll call this function, because the normal thing to do when you create functions is to call them. We'll call it right below initializing our camera. So just copy the name, and we'll say world. Great. But that's not all. So remember when I said that a system is what manages components? Well, we don't have one right now that's managing our player component. So in this case, when we have a component, well, okay, let's restart. When we have a component in a system, it will be automatically registered in the world, and its storage will be initialized. The dense vec storage that I mentioned first. So we have to register it manually, but that's no big deal. We can do it pretty easily just before initialize player. We can just say world.register and some fancy writing. World register player and call it. Good. But as you can probably guess by now, and as I mentioned, if we run cargo run, we'll still not see anything. And that's because our game doesn't know what Pikachu looks like. So let's remedy that by importing our Pikachu sprite sheet, which, full disclaimer, getting from this GitHub repo. Let me open it. From the same people that recreated that Pikachu volleyball game from in the web that I was playing in the beginning. And of course, I'll add the link in the description. And anyway, I'm getting this sprite sheet right here. Pretty convenient. So I have it in my downloads folder, hopefully. I did not. Okay, let's just save image as, and we'll save it as sprite sheet. So there you go, you can see me getting the image. Great. But the sprite sheet isn't good enough. We still have to create a spritesheet.ron file where we'll indicate where in the sprite sheet to get the image we want, right? Because if you see, this is the sprite sheet, and we have several things in here. We have several Pikachus, we have several Pokeballs, we have text. So we have to indicate where to cut the image to get what we want. Which conveniently, these people already wrote for us. So if we scroll down here, I think line 379, we have Pikachu 00. And this is pretty much what we need. We need to tell where we'll start cutting from, namely X and Y in this frame. So X and Y, and how long to cut for, which is namely width and height. Okay, so let's open this and we'll create our spritesheet.ron file inside of our config. So we'll say sprite sheet, or actually no, we'll create a folder called assets, and then we'll create images. Right, and then in here we can bring in the image that we had, that we just got, sorry, and create the spritesheet.ron file. Right, in this spritesheet.ron, I already got all the things that we need. So texture width, texture height. This is just the full size of the sprite sheet image, which, if you don't believe me, and we can open in a new tab, and you see in the new tab 476885. Oh wow, I did get it wrong. Huh, good thing you didn't believe me. 885. And in here, sprites is just the values that we just saw. So 2, 266, and 64, 64. Which now I'm questioning myself, so let's just go check real quick. I think it was Pikachu. There. So 2, 266, 64, 64. All right, that's right. Okay, so with all the groundwork done, let's actually load the sprite sheet in our Pikachu volleyball.rs. And now, to be honest, this is just a bunch of boilerplate, so I don't know, bear with me. First, we'll add our imports. So in here, let's say, comma, and place that in. So we're getting a render and we're getting stuff from assets. And second, we will create a load sprite sheet function, which I conveniently have on my second monitor. All right, paste that in. Okay, so we have a lot to unpack. So first, we are creating a loader, which is a resource that will help us get our PNG. Next, we are creating an asset storage, also a resource, and that is where our .png will be loaded onto. Lastly, we make use of our loader, which you can see right here. Okay, so loader is getting your PNG, and then text storage is where it's being loaded onto. Okay. One thing to note is that a loader call can be used on all sorts of things. So we have to specify that it is an image, say an image format. Okay. Actually, a good example of that is what we're doing right below. So in here, with our .ron, we follow the same pattern. But note that this time, instead of saying sprite sheet, instead of saying image format, we say sprite sheet format, and we're giving the texture handle that we got. Right, so we're pretty much just giving it what to cut. Okay, so taking a sneak peek at this load method, we see that it returns a handle, right? So that explains the last aspect in our function stages, right? So we're giving back a handle sprite sheet. All right, having the function, again, the natural thing to do is call it. So let's do that right before initializing our players. Where did we initialize our players? We did it in the onStart method. Right here. So in here, we'll say load sprite sheet, and it wants the world as well. So we'll give it the world. Great. Then we have to go to our initialize players, and in here we'll add one more parameter. We'll add the parameter sprite sheet, which will be of type handle. Then, right after setting up our transform, we will create our sprite renderer. So right here, we'll say sprite renderer, sprite sheet. We'll give it the sprite sheet that we just got, and number 0. And now this number 0 is indicating which element of the sprites array inside our .ron we want, right? So in this case, we want Pikachu. Of course, we don't have any other element right now, but we could have, and we will have. So then you use them. Right. Anyway, now let's add another width right before categorizing our entity as a player, where we do a sprite render .clone. Right. So of course this is telling Amethyst what Pikachu looks like. And note that we're doing it for both of them, right? Because we're using the same sprite sheet, as I also mentioned previously. One thing to note is that this clone is actually not bad at all. Remember, our load function is returning a handle and not the sprite sheet itself. So by design, we're avoiding any deep cloning whatsoever. And I note that we have an error. That's because this is a handle of type sprite sheet. Oops, did I delete stuff? Alright, that should be good. And oh no, did I delete stuff? Let's just go back a bit. Oh, I deleted a bunch of stuff. Okay, so in here, my bad, we'll add sprite sheet again. Sprite sheet. Okay. Hopefully it didn't control Z anything that we needed. But yeah, no, it looks good now. So the moment we've all been waiting for, let's cargo run it. And I'll probably have to cut the video unless we get errors. which I won't cut. Let's fix them together. So, initialize player supplied one argument, of course. We loaded our sprite sheet. So we want to get the sprite sheet, right? And we just loaded the sprite sheet but didn't put it inside of a type, so we'll say load sprite sheet, and then we'll pass in the sprite sheet right here. Right, was that the error that we had? Looks like we have more. I am re-importing the camera. That's what happens when you copy and paste, you know? There we go. Then select storage is also re-imported. No way. What? Oh wow. When did this happen? Okay, camera, let's place it right here. Can't delete this one. And okay, let's just go through problems right here. Unresolved import. Oh, that's not in our component. This is all Amethyst stuff, so we don't have to care about it. In here, we're missing a semicolon. And in here, expected semicolon found world. Okay, yeah, we just added semicolon. Alright, so we should be good. Let's do a cargo run. And now we're good. So I will cut the video and be right back. Alright, we got more errors. With cargo run, you see that we didn't get our Pikachu. So let's close it and let's look at this. Alright, so from looking at this, it's telling me that we have an error. OS not found. Okay, so no such file or directory. Aha. So you see here, it's expecting assets, texture, sprite sheet. So probably when I was sort of working through this before, instead of calling this images, I called it texture. So let's just do that. Easy enough. Texture, and I think that should be it. Right? If we Control F, we see that we were expecting texture sprite sheet.png. Right, same thing here. Texture sprite sheet.run. But no worries. This is something that we'll have to get used to with copy and pasting. But there we go. We have our Pikachus. And perhaps the display.ron is way too big. Initially I had it as 500, so maybe we can go with that. Let's try it out. 500, and of course don't forget that we have to change our arena size to 500, and now let's cargo run it again. Yeah, probably better if I cut it back. And I think it's looking much, much better. Alright, so that is it for adding the Pikachus. Now let's move on to as first order of business to start moving Pikachus around, we'll create key mappings. So inside of our config folder, let's create another .ron file called bindings_config.ron. Okay, and inside it we'll add this. Okay, so we have axes, which will be left player, right player, and actions, which is just empty. Now the left player will be moved with keys D and A, and the right player will be moved with the right and left arrow keys. We don't define any actions in here, like, I don't know, attacking, because we don't really want any of that. But the object is still required by the bundle where we'll make use of the .ron file. Talking about making use of it, let's go to main.rs, where first of all, we'll add a couple of inputs. Sorry, not inputs, imports for input. And then right below where we got our display.ron, let's get our new .ron file, which we'll call which is called bindings underscore config. So we're getting config binding path from the config.dir, and the name, right? Now right below it, we'll get the input bundle, which, as the name suggests, will give us what we need for inputs. Okay. Of course, when we have a bundle, we have to make use of it in our game data. So in here, we'll add as our top bundle the input bundle. Okay. All right. So just like our transport bundle allowed Amethyst entities to move around, the input bundle allows Amethyst to listen to key presses. But well, of course, listening isn't enough. We have to tell the engine how to respond to the key presses. And to do so, we'll create our very first system. So let's start by creating a folder inside of source called systems. Okay. Now at source root level, we'll create a file called systems.rs. Now if you've watched my video on modules, you see that where this is going. And okay, so the idea is that in systems.rs we'll hold sort of references to all the systems that we'll create inside the systems folder. Okay, so let's create our first system. It will be called player.rs. So this will be our player component. And inside of system.rs, as I mentioned, we'll add our player module, just like so. Okay, we haven't implemented this yet, but we will in just a second. Actually, we'll do it right now. So inside of player, we'll put all this. Let me remove this and close this for now. Okay. So there's a lot going on in here. So first things first, I already told you what a system is conceptually, but in code, all it is a struct, just like so, that implements the system trait. Okay. Now, because we don't want to load every resource / component and entities in every system, we have the system data here, where we specify the type of access that we want to a resource or a component. So, for example, with read, we have we're getting an immutable reference to the input handler resource. With read storage, we're getting an immutable reference to the entire storage of the player component. And with write storage, we're getting, well, a mutable reference to the entire storage of the transfer component. Whenever you have storage, you know that we're dealing with components, and whenever you don't, you know that you're dealing with resources. Okay, now we have this run function. And before we get into it, quick pop quiz question. Where are we even calling it? Well, thing is, we aren't, and we won't. Not explicitly, that is. You see, when the engine starts, something called a dispatcher will try to execute systems repeatedly, and it does so by calling our run functions. So we don't have to worry about making any explicit calls. Alright, that aside, getting into it, you see that we're getting access to, well, everything that we have inside of system data by destructuring it. So we have our transform, players, and input. And we make use of it. So first of all, we create this movement variable. Oh, that's a typo. Access value. And we set it to a specific input access value. So, and of course, this name in here has to be the same one that we gave in the bindings config file. So we can now use an if let in movement, because input access, it returns an option, and you can't see so, or you can't see right now. Actually, let's make it so that you can see it. Let's go to main, and in main we will add mod systems. Now, just like so, we will have access to the data that we need. So there you go. You see, input access returns an option. And so we can use iflet. That was my whole point behind this. So after getting the iflet, we'll have this f32, which basically just indicates the direction that we're going. So if we're going to the right, it will be a +1. If we're going to the left, it will be a -1. So we check if it's not 0, then we get our side name, and we're doing this just so that we can print it, and we'll print side moving Okay. Alright. Before we can run this, so we can see the results of our print line, let's go to main and just make use of our system. So we already got the system's module declaration here. Now we will just go right below our input bundle, and we'll add a with statement, which is for systems. So in here we have the system, the system player system with a name, very creative player system, that has a dependency on input system. And this input system, we're just sort of getting under the hood from the input bundle as we saw before. Okay. Oh, and before I forget, remember when I said that we had to manually register our player in the world because there wasn't a system for it? That's not the case anymore. So let's go to our Pikachu volleyball.rs, and we can safely remove this ugly register. Okay. Now let's just bring back our console and do a cargo run. Doesn't look like we have any errors, so we'll be right back when this finishes compiling. And there we go. Now let's test it together, and you can see in the console at the bottom of my screen, I am pressing the side right. I'm pressing the left arrow key, so you see that we're getting a -1. Now I'm pressing the right arrow key, so side right's moving +1. Now I'm gonna press A. You see that we're moving -1. Press D. You see the left is moving +1. So there we go. Now that we have confirmed our success, we can close this. Oops, let me close that. And now I would like to go back to the player.rs file to just sort of address a couple of things that I brushed off. No reason for the brush off, but just for completeness. So a lot of people, they want to see how lifetimes are in actual code, right? So here's a great example for it. See, we have this system with this lifetime called S, and the main point of this is that we want to make sure that the resources and the components that we're using live as long as the system that we're creating, right? Otherwise, it's no good. We have an input handler that dies before our system is done running, then we won't have any key presses to handle. So that's lifetimes. Now in here we have join. I don't think I've gone over join in any of my videos, but it's pretty simple, and I think the description is pretty self-explanatory. It says creates a joined iterator over the contents. So we could iterate over players, we could iterate over transforms. This what it does, it creates an iterator that allows us to get sort of this tuple of player and transform. Yeah. Oh, one last point. This system desk derive, it stands for system descriptor. And usually when you're implementing your own system and you have to access world resources inside it, you gotta write an implementation for the system descriptor where you specify how this access will happen. In our case, we're not doing any of that. So I think the default implementation works just fine. In fact, I don't even know if we need a default implementation. because I was taking a look at the Amethyst book, which, by the way, I'll also put in the description. And if you take a look at this, these are the benefits that it gives us, and I don't think we're using any of it. So, yeah, I don't think it's extremely necessary, but seems to be good practice to put it in, so we do. And the game runs just fine without it, by the way. Right. With those details out of the way, let's finally move some characters around. So let's go to player and define a new constant right above the system descriptor that we were just talking about. We'll say const will be player speed will be an F32, and now this you can tune the game to your liking. Testing it out, I found 128 to be good, at least in my previous tests. Let's see if it still applies. Spell player. And we'll make use of the speed in just a second. Now, in system data, I want to add one more resource, read access, to a resource called time. Oh, and of course, before I forget, let's also bring in time. I don't think we did. From core timing time. Okay. Now we'll use all that to scale the movement amount to something that makes sense in terms of world coordinates, right? Because if we were to just use the movement amount that we have right here, we'll be moving like 1, and that's no good, or -1. Okay, so inside of our if let, let's add, or actually let's replace our entire if let with this, because we're not really doing anything much. There. Not replacing the entire if let, I'm leaving the movement amount. Okay. So what are we doing here? As I mentioned, we're using this player. Oh, what is this? That might be a Rust analyzer error, or am I missing something? In any case, let's try piece of advice. Something I always do when I have these sort of problems, I just reload the window, and most of the time it just clears it. Now, of course, you'll have to sort of rerun Rust Analyzer, but I find it worth it. Anyway, if we see that player speed looks fine now. But one thing that we still have to do is we have to bring in time from the system data, the structuring right here. So we'll say time, and then we have access to time here. So that gets rid of the error that we had. Okay, so again, getting back into it. Player speed allows us to have direct control on how fast our character is, right? Because we can't control movement amount or time, so this gives us the possibility to really just fine-tune it. And if you're following along, feel free to make it whatever value you like. Now, we multiply it by time delta seconds, because remember, this is velocity, right? So we'll be, say, meters per second. So multiplying by time, you cut off seconds, and then you just have meters, which you can multiply by the movement amount to get the direction. Yeah, so that's looking good. Next up, we get our player's current position, because what we want to do is we want to get the scaled amount, which, again, as I mentioned, this is speed times second times direction. This will give us an amount of, I'm lacking the words, but distance. There we go. Distance. Thank you. And we'll get the player, our current position, and we'll add a certain distance to it, or subtract in case this is negative. Okay. Other than that, we also set a player left limit. So if we're on side left, our left limit is 0, right? The one side of the screen. If we're on the right, our limit is arena width times 0.5, which is the middle of the screen, where sort of our invisible volleyball net is at. Okay. Now we're doing some clever math, I guess, to sort of set our boundaries. Because if we just say, if we didn't have this, and we just set the translation amount by player X and scaled amount, we could move off screen, right? And we don't want that. So what this does is you take the max with the min, and you take the min with the max. What am I saying? So for example, say that we have a current position of 110. Okay, say that our minimum boundary, I'll call this min boundary, is 0. And our max boundary is 100. Right, so we're currently off bounds on the right side, or on our max boundary. And these are all x positions. So by taking 110 dot max 0, the maximum of this is 110. Right, so what that's telling us is, hey, you're not off bounds on the left side, so I'll keep your position as is. Now we take the result of this, right? So this, which of course is equal to 110, and we take the minimum with our maximum boundary, 100. Now the minimum between 100 and 110 is 100, so great, that's keeping us in check. And I think that is all we need to get the program running. So let's do so. Let's bring back our console and do a cargo run. And doesn't seem like we'll get any errors, so I will be right back. Okay, our code finished compiling, so moment of truth. I will press the left arrow key, and there you go, our Pikachu is moving. It cannot go off bounds, so you see I'm hitting the wall and it's just staying there. It's where I'm pressing. And I cannot go through the invisible net. It stops right there. Same thing for the left side Pikachu. Okay, looking great, but our Pikachus don't have much to do right now. So let's give them something to do by honestly, creating the ball component is no different from creating the player component. But first, let's go back to that very useful GitHub repo to get where we will cut the ball sprite from. So you can see right here, it will be x88, y 158, and we'll have a height and a width and a height of 40. So conveniently, I already have it set up in the way that we have to put it in our assets texture spreadsheet.rom, and there we go. Probably don't have a formatter for this. There we go. And should look good. Oh, by the way, my RON files, they look like this because I installed an extension for it called VS Code RON. So if you want them to look the same, just install this one. It looks pretty nice. Alright. That aside, we now have where to get the Pokeball from. So that done, we'll pretty much just follow the same gist as the player. One, create our ball properties right below the ones from the arena. Right, so we'll say, let me copy it from this side and bring it in here. Actually, no, let's not put it right below the arena. Let's put it by the end. This way we can easily just distinguish each section of the video, or as well as we can. Now, I want to change these values. I'll put maybe 128. The ball radius, we cannot change it. And okay, so number one, create the Pokeball properties right below or not right below the rest of the code. 2, let's create the Pokeball struct and implement the component trait. With that, we can use dense vector storage as well. So Pokeball, we have a velocity, which is a tuple of 32s, a radius, which is an F32, and we implement component for Pokeball dense vector storage. Ooh, and I just noticed we're doing this in the wrong place. We're doing this in Pokeball and player.rs. That is not what we want. We want to go back to Pikachu Volleyball. My bet if you were following along and I had to cancel it. Perhaps I should have put it below the arena. That would have made you notice. But anyway, put it right here. And now, just like the player, again, we'll just create our initialization function. So right here, I'll paste this in. Now let me make our code larger. And well, I was renaming these guys to Pokeball instead of ball. And there we go. So, pretty simple. We get a transform and we put the Pokeball right in the middle of the arena and at the same layer, the Z layer, as the Pikachus. So, arena width times 0.5, arena height times 0.5, that will give you the middle. Now the sprite renderer, remember before it was 0 because we're getting the 0th element. Now it's 1 because we're getting the first element. Sprite sheet is what we're passing in. We'll do the same. And oh, again, this is not ball. My bad. Pokeball. And then we create entity with sprite renderer, just like player. And then with Pokeball, this is what defines this entity as a Pokeball. And then with local transform, and we build. All just the same. Of course, we still have to call the function. So let's go up to our on start, and right here we will say world and sprite sheet. Right, it's just the same sprite sheet, right? The sprite sheet's always the same, just position is different. And in here we just have to do a dot clone. Again, this is really no issue because it's just the handle sprite sheet, right? And this should work just fine. Let's do a cargo run. Doesn't seem like we've got any errors, so I will be right back. I spoke too soon. We did get errors. You may ensure the resource exists. We tried to... Okay. Try to fetch resource of type masked storage Pokeball from world, but the resource does not exist. Alright, what that tells me is that we have this Pokeball component that does not have a system. So we have to, you guessed it, we have to register it. And we do so by saying world dot register, and we'll say Pokeball. Oops. Where were we? You see, on my keyboard, I have page down and page up keys right above my arrow keys, and so I always accidentally press them. But anyway, that should be now good enough. Let's do a cargo run, and hopefully we won't get any errors this time, and I'll be right back. And there we go. We got our Pokeball in the middle of the screen. But if we move our Pikachus around, oops, I have to click in here. You see that they have absolutely no chance of reaching that Pokeball. So I think we should tell that Pokeball that it... Okay, and to do that, we'll create a new system. So let's go to our systems folder. And in here, we'll create a new file called pokeball.rs. Okay. Now let's go to our systems.rs, and in here we'll add pretty much the same thing we added for player. We'll say mod Pokeball, and then use Pokeball, and then Pokeball system, which again is what we'll implement in a bit. Or again, right now. Let me just copy the code and right there. All right. So, same as always, a bunch of imports. bringing our Pokeball in from an absolute path from Pikachu Volleyball Pokeball, creating our Pokeball system as a struct that derives from the system descriptor. Next, we create just properties and then implement system, which makes this an actual system. Okay, so just like last time, we are bringing transform as write storage, time as read. The one difference is that we're bringing our component as write storage. Because as you see, we're editing its properties and values at the end in this line right here. Right, so we're editing something that's from the Pokeball component, so we have to allow writing to it. Anyway, to move the ball, we are using this function called prepend translation x. Now what this does is we'll get our current position and it will add onto it the value that we pass. Okay. And now you may ask yourself, like, okay, but why didn't we use this previously, right, in the player.rs? But note that here we had to use set translation x because we had to check the max and the min. So prepend wouldn't work, right? Because we'd have to pass just the scaled amount, but we don't want to take the max and the min of the scaled amount. Okay. So let's go back. In here, we pretty much just do the same as before, right? We have velocity, so we have to multiply by time to get distance. And in here, we have a velocity and we have gravity acceleration. So we're going to multiply gravity by time. So gravity, it's, say, velocity per time, right? So we multiply by time, we have velocity. Both of them are dimensionally the same, so we can add acceleration with velocity. Now we can multiply by time delta seconds, again, to get position. Great. So we've updated our translation x, right? So it's moving on every run. And then we update our velocity. And we're doing so because, well, the ball must accelerate with gravity. Okay, as usual, we have to bring in the system in our main. So maybe we can do it right below the player system. Let's add this following line. So with systems from Pokeball system, we're giving it the name of Pokeball system, and it doesn't have any dependencies. Let's close this, bring back our console, and do a cargo run. Doesn't look like we have any problems, so I'll be right back. Oh no, you missed it, I think. Okay, let me close it and cargo run it again. It shouldn't take too long. There we go. And the ball falls off the screen. I'm running one last time. You see that the ball is moving, so great, but we're not setting any constraints to it, right? Like we were doing with player. Now, instead of using prepend, we could technically also do the same max and min, right? But we're not just changing x, we'll also have to check y. But I don't know, to me that just seems inconvenient, right? Because we also wanted to hit the player, so anyway, we can do better than that. And so let's do that. And we will do better than that by creating another system. So let's go to the systems folder and we'll create a new system called bounce.rs. Okay, because we want our Pokeball to bounce. Great. Now, just the usual, go back to systems and we will have to add mod bounce, and we'll say use self bounce, and then bounce system. Okay. other than doing that, let's already go to main and get the bounce system out of the way. So just like so. Note that we're getting it from the bounce system, just like we did in the systems.rs. We're giving it a name of collision system, and we're being a little bit more imaginative this time. And we have two dependencies, right? Player and the Pokeball system. And that's because, well, we're moving the Pokeball is what's going to be bouncing off of things, and it's also going to bounce off our player. Alright, so with that done, all we have to worry about is implementing the system itself. So let's come right here and do so. We will add this to the file. Okay, now you're seeing this, and it might look sort of complicated, but it really isn't, and we'll just walk through it. Okay. As usual, imports, we know you're bringing some stuff from Pikachu Volleyball, bounce system, system data, you know, all that stuff that we already went through. What I want to get to really is the part that sort of looks like, oof, a lot. To show you that it's really not, it's fine. Right. Oh, one thing I want to point out, in here, we had this for loop on players, right? And I feel like it didn't really need much explanation because, well, we have multiple players, so it sort of made sense. But you see that is not just because we have multiple players, but that's a pattern that we follow all throughout, right? We had it in Pokeball.rs, even though we don't have multiple Pokeballs, and we also have it in Bounce.rs. So that's just something you can always follow. Of course, always beware of always, right? But anyway, in here, the first one, so this first condition is the floor. So in the floor, y is 0. So if our Pokeball reaches sort of the ball radius, that's when we tell it that that's as far as you can go. Now the second if, try to guess, what is it? We already know that that this one is the bottom. So we have left the left wall, right wall, and top wall. Looking at this, which one do you think it is? This one, it's, well, easy to guess because we have arena height. If you get it wrong, don't worry. But yeah, this is the ceiling. So, sort of the same logic as here. You know, the Y position is arena height, and then we subtract radius because that's what will allow it to go that far, right? Otherwise, it will pass through. Same idea as the sprites that we had before. And in here we have this is the right wall, and this is the left wall, and this one is the right wall, right? Because this is the full width, and the left wall starts at 0. So that's it. And if you didn't really get this, I have another good image to show you, which will probably just be just as pixelated as the other one, but we'll make do. Alright, there it is. Again, this is from Xing Liu's book. In here, the bottom, ball radius, that's as far as we allow it to go. In the top, arena height, minus the ball radius, that's as far as we'll allow it to go. In here, ball radius, that's as far as we'll allow it to go. And in here, arena width, minus ball radius, that's as far as we'll allow it to go. Alright, repetition aside, I think we should be good to run this code. So let's close this and open our console and do a cargo run. Now, alright, seems like we got a couple of errors from problems. It's telling me that we have 3. So let's go check them out. Invalid expression. That's because we have a semicolon while we shouldn't have. And those were all our problems. Great. You love easy problems, you know. Now we can cargo run, and I don't think we should get any errors now, so I'll be right back. Alright, this time I didn't have to rush, because as you can see, our ball can no longer escape the little prison that we put it in. it will just always all right, jokes aside, that is happening because I'm guessing we're getting like a tick where the ball is inside, so it keeps on changing direction instantly, right? Because it is, or actually, is this the, yeah, so this is the floor. So it passed through before the check happens, and then the check occurred, and then it changed direction. But then the next check occurred, and then it tries to change direction again, so it went inside, so it just kept on, you know. So what we have to do is we have to add another check here. So we'll say Pokeball dot velocity dot 1 is less than 0, right? And so that means that the ball is falling, and then we want to change it. Otherwise, keep it the same. We don't want to shift it again. Now we can copy this for the other ones because the logic is, the logic is mostly the same. Of course, we have to just change the, if it's X or Y, right? So in here, we're still, this is height, so this is Y, but it's not less than 0, it's actually larger than 0. In this one, we are on the left wall, so we are looking at 0, and it has to be less than 0 because it's going to the left, so that's negative velocity. And in this one, also we're looking at 0, and it has to be larger than 0, so it hit the wall. Alright, now if we cargo run it, we don't get any errors, and I'll be right back. Alright, and this time, let's not jinx it, the Pokeball will not escape the prison that we put it in. Okay. But that's not good enough, right? I want us to be able to hit the player, and if the player runs in front of the Pokeball, you see that it just passes through it as if it did not exist. So, we will have to, add collision to the player, right? And the easiest way to do so is to sort of simulate the player as a rectangle. So, still in our bounce.rs, let's add a helper function. So let's go right here, and this helper function will tell us if a point, the point that we want to know is the pivot of the ball, right? So the middle of the ball is inside a specified rectangle, and a rectangle will be the player. So yeah, we'll use this function when we're checking if we have to bounce back. Right, so we'll check. We will add it right here below the other checks. And now note, here we're doing this for loop for Pokeball and Transform, but now we'll be interacting with things like player position and whatnot, so we have to do this other for loop where we have player and player transform for, the player, of course. Alright, now we do the if with the helper function that we created. And as mentioned, the pivot that we'll be looking at is the Pokeball. So we want to check if this point is inside of this rectangle. Now this rectangle is just sort of a rectangle expanded off of the player's dimensions for the Pokeball, which is the same idea as the walls, pretty much. So you have a rectangle, which is delimited by player X, player Y, and player X plus the width, player X plus the height to indicate, right, the right side, top side, left side, bottom side. Now we will subtract the radius so that our rectangle that's like this from the player will be like this. Does that make any sense? Hopefully it does. If not, just ask me in the comments and I'll draw pictures and I'll find a much better explanation. Anyway, we then if we find that the ball, now this is for the same glitch that we had before, right? We want it to be trapped inside the player. So if it is less than 0, right, that means that it's falling because this is the Y velocity. We will completely alter the direction of the ball. Okay, great. So now if we run this code, we won't get any errors, and I'll be right back. Great. We did not get any errors, and as you can see, it's working. But it's, not very interactive, right? As you can see, we don't have to move, and we just sort of draw this stalemate forever. And one way to fix this is to just add some sort of random component to, say, the X or the Y component of the ball's velocity every time that it hits the player. And yeah, it's a pretty easy fix. I'm usually against adding sort of randomness to things like this because, well, it doesn't take much skill to be random, right? But this is just for educational purposes, so it's a cheap game mechanic that we'll have to live with. And do note that the ball is, it's falling slowly because of gravity, so its arc is, becoming smaller and smaller, but still not enough of a change to make our Pikachu move. Anyway, let's close this and let's open this. Let's go to our cargo toml, and in here we'll add a dependency to the rand crate. Now, if I remember correctly, the random crate is at 0.7 version now. And let's go to bounce again. Alright, so now back in bounce, we will bring rand RNG into scope, and with that into scope, we can now create a random number generator, which we'll call RNG by doing rand thread RNG, yeah. And then in here we'll multiply the X velocity by RNG, and we'll generate a range of numbers between 0.6 and 1.4. And these are just arbitrary numbers, but I've found that they work well. Oops, looks like I removed that. And yeah, I found that they worked well. You can, again, just feel free to tune the application however you like. But let's save that. Now open this and cargo run. This will run and I'll be right back. And there you go. As you can see, we already have much different trajectories. We're even hitting the ground, hitting the walls. So hopefully I can get the ball out of, oh, it actually did go into right's court. Anyway, there we go. Getting distracted playing the game, but you get the idea. The game is now much more dynamic. And yeah, great stuff. Now that we have a ball that moves around, I feel like the next logical step is to how? Silly to ask. We'll create another system, of course. Okay, so same good old story. We'll create a file called winner .rs inside of systems, and then we will go to systems and we will add our mod. So I just copy and paste it. I'll say winner, and this will be winner system. Of course, this will be inside of winner. Okay. Good. Now we go to main.rs and we will add our winner system to our game data, just like so. I think I have a semicolon by the end. Let's remove the semicolon. So a system inside of a system inside of called winner system, or name winner system. Dependencies is the Pokeball system, right? Because it's dependent on where the Pokeball hits. And you'll see how we'll use it in a sec. Okay, now let's actually implement the winner system, and we will do so by copy and pasting text. There we go. Alright, so if you're following along, let's go through it. Usual. Usual. Alright, so we don't need to go over it. Still have any questions like, oh hey, why is this write storage? Ask me in the comments and I'll be happy to reply. Anyway, run. As I mentioned, we are dependent on the Pokeball system running because we're using Pokeball coordinates. So we check if the ball has hit the ground, right? We can do so just by, I feel like we even used this check before, so yeah, pretty self-explanatory. Then we can check X, and we're checking X to determine which player scored, right? So if it's less than arena width in the middle of the arena, then we know that the right player scored. If it's larger than, then we know that the left player scored. So this being all good, we change the position of the ball. So say that it hit the ground, we then respawn it at the middle of the arena. Okay. Next up, we then just change the velocity, right? So if it started off serving the player on the right, it will then start serving the player on the left. And that actually should be good enough for our first test. Let's open our terminal. Let's close this and do a good old cargo run. Don't think we have any errors, so I'll be right back. Alright, the game has started again, and oh, there we go. The ball just hit the ground, so we see that left plate score, then right. Let's try and avoid that. Better with this one. Now let's try and score a point for left. Well, left has been very unlucky with these RNGs. No, is that enough? Oh my god, nope. See, great game design. Oh no, right player scored. Oh, there we go, left player scored. So we see that things are working, and our velocities and things might not be the best, right? So we might have to tune it a bit, but we get the idea. Great, but of course, displaying in the console isn't good enough, right? We don't want the user to try and keep track and or even check the logs. So we want to add UI. And to do so, let's go back to our main and add the following imports from Amethyst. So we'll add a comma and we'll import UI, render UI, and UI bundle. Now, right before the rendering bundle, we will add the UI bundle that we just got. Okay. It uses string bindings just like the input bundle did. Okay. And then we'll add a plugin right below the other ones. So let's remove this comma, add the plugin, and the comma is right here. Okay, so we're adding a plugin to the rendering bundle so that we can render the UI. Now let's go to Pikachu Volleyball.rs. Close this again, close this. And we'll create a struct for our scoreboard. Let's go down to the bottom. And you see, I'm not really organizing my code very well, right? I'm putting one thing below the other, below the other, below the other. But hopefully that helps you if you go check my code on GitHub to just sort of, I guess, follow along. I don't know. But yeah, note that we are deriving from default, just so we can use the default values for both i32s, which is 0. Okay, so with that done, let's go back to our new system, which is Winner. And in it, we will bring our newly created struct into scope. So in here, it's from Pikachu Volleyball, we'll say scoreboard. Okay. Now in the Amethyst imports, we want to also add right, because we want to add write access to the scoreboard. And important thing to note that it's write and not write storage that I'm giving, and that's because scoreboard, again, it's not a component, right? So just keep that in mind when you're writing your own games and whatnot. So we'll say scoreboard. Okay, that is looking good. Of course, we still have to destruct our scoreboard. We'll say, I think scores should be a good name. Now, instead of print lining the score, we'll increase the value of our score right and then left, right? So let's replace the if that we currently have with this. Now, if me mumbling didn't make any sense, hopefully you've seen the code, it makes more sense. I get score right, and then I increase it. Oh, and I'm setting a maximum value of 999 just so that it doesn't overflow the screen, and I don't think anyone's gonna play our game for that long. Yeah, so now that we have the actual score values, we have to display it on the screen with UI text entities. So back in Pikachu Volleyball, let's bring in a couple of imports. Let's go all the way up. Close this. And in here, we'll bring in from UI, anchor, DTF format, UI text, and UI transform. Okay. And now we will actually implement the score text. Now, this score text implementation is not very pleasing to look at. So honestly, I just recommend that you go on my GitHub and you copy and paste it, because it will be very annoying to just write this down. But anyway, we create this. We're creating the UI transform, which sets the position of our text. Okay, so I'm right here. We're creating this UI transform, and so we'll give it an ID. We'll set an anchor. We'll set a pivot. The pivot is just like what I was mentioning before, right? The pivot is in the middle. Same idea. We'll set an X. We'll set a Y. We'll set a Z width, height, and again, play around with the values. Find what works best for you. You know, right now I'm putting it sort of in the middle of the screen, at the top. But I don't know, maybe you want to add to the sides. Try it. See how it comes out. Same idea for here. And then, having the transform, we can create our entity for the scores. So, if you want score, world, create entity with transform component, and then also with the UI text. Right, so this is the same idea that we had before for the like the camera, the player, whatever. This is our sort of categorizing component, UI text. And this is a new for font clone, which, by the way, I think I sort of skipped through it. This is our font, right? We're using a loader, same pattern I think that we've seen before. And we're bringing a something from a folder called font, called Square TTF, of TTF format. This is just an empty tuple. This is a progress variable, and it helps with things like error handling and whatnot. We're not really doing any of that because the video is already long enough as is, so we're leaving empty. And yeah, world resource. Okay, so yeah, we'll be using this font, and we'll be setting it as 0. This is the color value, so 111. This is I think it's called linear, right, for RGB. So this will be white, and so on. Feel free to, if you have Rust Analyzer, something you can do is you can press F12 to go to a definition of something. Rust Analyzer seems to be sort of annoyed at me on my computer. I think it's probably because I'm running OBS, my editor, and Rust compilers and programs. I'm doing cargo run once every 10 minutes. But anyway, in your own time, install Rust Analyzer. You can do F12 and you can read about all these properties. Okay. All right. Seems like that stopped loading, so that's good. We can go back to coding and initialize. Go back to coding where we will initialize our scoreboard. Oh, actually, I didn't mention this. We created this score text struct, which is sort of a wrapper around these two entities. These two entities being just the UI text. And we created this wrapper just so that we can easily get it when we're using the system data. I will have to bring both of them individually, we just bring one. Pretty convenient pattern. Oh, there we go, Rust Analyzer loaded. Okay, as it's telling us, apparently we have errors. See, Rust Analyzer is very convenient. I think we just have to bring line mode from the UI. Yeah. Right. Looking good. So I was saying, let's initialize our scoreboard. To do so, we will, as usual, go to our on start and initialize scoreboard. As usual, giving it the world. Looks like we have two problems. Let's address them already. Seems like we don't have entity in our scope, so Rust Analyzer always helps us. Tells us to import entity from ECS Amethyst. Let's just go up to organize sort of our imports, because I think we did import something from Amethyst, from ECS. We did. I think we can bring it from Prelude. Yeah, and we don't want to duplicate it, so let's just erase this guy. Oops. That should be good. And no more problems. Great. Oh, by the way, let's just go back to our on start. I just noticed that we never removed the register for our Pokeball, right? So let's just do that. That's because we have a system that's initializing our Pokeball, so we don't need it. It was just sort of doing, dual work. And yeah, but we're not done. Remember I mentioned that we have this font file, font square TTF? Yeah, so we're not bringing that in. So let's do so. In our assets, we will create another folder called fonts or font. And I have this this font here called Square TTF in my downloads folder. You can just get it from my GitHub repository. Okay, and that should be good to go. Yeah, let's just cargo run. Let's just cargo run. Cargo running this. No errors. I'll be right back. All right, and we are back. But unfortunately, you're seeing it run because I fixed the error, but there was an error. So let's just close this, and I want to take us back to where the error showed up. Let's make this full screen. Okay, so right here, inserting it. We got that error that I don't have to read it. We got the same error that showed up, or pretty similar to when we didn't have something that was registered, right? We remember we got this error when we didn't register the Pokeball. Yeah, so I was like, but we don't really have to register anything new, right? So my new guess was that we were importing one of the bundles in the wrong order, and it seems like we need the transform bundle before we can have the UI bundle. So all I had to do was get the transform bundle, which was before my last bundle, and bring it above the UI bundle. And that was just enough to fix the error. So if I just cargo run it right now, I don't think it should take too long. And, oh, where is it? Oops, my bad. It went to my second screen. And there we go. You can see that we have the values, but the one problem is that, well, they don't increase. Right, so it'll always be 0. So that's our next step. Okay, and to do so, let's go to our winner.rs, and in here, let's add score text and UI text to our system data. So I don't think we should have any errors, right? We should be bringing everything that we need. Yeah, we have UI text here, and oh, we're not bringing score text, so let's just bring that in. Good. Now in our parameter list in here, we want to update it to say, mute score text, mute UI text. Okay, just to account for these two, right? And we want to add on stuff in here, right? So before we had the print lines, which would display the stuff. Now we have actual UI, so we're sort of replacing that UI, or replacing the print lines with this. So that in there, and this in here. So here we're pretty much just doing a Rust equivalent of a null check, if I'm being honest. And then updating the score to score right and score left accordingly, right? So we check, hey, UI text, we get mute, and if this is sum, right? So if we have a P2 score entity, then it's not none, it's sum, we have text, and then we get the text property of text, and we update it to score right, which we already incremented. Same logic for left. Okay. And yeah, we should be able to cargo run it. And I will be right back. Oops, looks like I missed a couple of points, so I spoiled the big display, but as you can see, let's let the ball fall. We see that we do get increments, right? So, well, technically we have a fully functional game. Great. Anyway, I know we're still pretty far from an actual recreation of Pikachu Volleyball. We'll still have to add backgrounds, a menu, like even an actual volleyball net, right, in the middle of the court. So as this video is getting quite long, I won't get into all that, but perhaps, leaving some challenges up to you. But one last thing that I wanted to implement is so I pretty much started this video with the Pikachu soundtrack, so I feel like it's just fair that we end the video with it. So let's get to it. To have music/audio in your game, you need the audio bundle from Amethyst. So we'll come right here, and from audio, we will import the audio bundle. Yeah. Not sure why we didn't get any IntelliSense, but I think that's correct. Alright, now, right before our rendering bundle, let's add in our audio bundle. Nothing too crazy here. And the sounds that we want to add to this game are mainly 3. We want to add 1, the background music, which is that Pikachu soundtrack that you saw. 2, the sound effect of when Pikachu hits the ball, which will be Pika. And 3, a sound when it hits the floor. So, yeah, once again, I got all these sounds from those amazing people from the Pikachu repository. And I have them in my download folder. You can get them from my GitHub repository once again. So it's these three: background music, hit, and point. So in assets, we'll create a folder called audio, and we can just drag and drop these guys in here. Right. Oh, one quick side note. Originally, these two files, they were .wavs, but Amethyst didn't like that, even though it supported the WAV format, so I had to use an online tool to convert them. Alright. Now, having this, let's create a file called audio.rs. This is where we'll do all of our audio work. And before we forget, let's already bring in or add a reference to our new module audio, and we'll say we're bringing in this crate from audio, which we don't have yet, but we will, and you'll see how it's useful. Okay, now inside of audio, we will add the following. Okay, so normal imports, yeah. And then here we're creating a couple of constants. This one is an array. These two are just strings. Then this is the struct music that you saw that we were using in main. This is just sounds, right? So this will hold our background music. This will hold score is when it hits the floor. Bounce is when it hits Pikachu. Format is an enum, a help enum that I created for OGG and MP3, which we use in this helper function called load audio track. Let me minimize this. So in here, we are, depending on the kind or the format of the file, we load a different loader with OGG or MP3 formats. All these provided by Amethyst. Then we load the file in relation to well, the path, right? With that, we then return the source handle, which is that useful construct to avoid deep cloning and all that. Right. With that, we have initialize audio, which is, as you can guess, the function that we'll call in our onStart. So initialize audio is inside this function, we will use this audio sync to set the volume to 0.25. So that's 25%, and I'm just setting it to 25% so we can hear the sound effects on top of the music. And next up, same loader pattern that we've used before. And then music, we're getting the audio music that we have, and this is why this one is an array while the other ones are strings. We'll iterate over it. We map each of the files, which in this case is just one, right? But you can have several soundtracks, if that's your thing. And we call our helper function, format MP3, providing the world, which is passed in here, and the loader that we just created. Then we collect it onto a vector and into iter. Then we cycle. The idea behind this is to loop over the music indefinitely, right? Because we don't want the background music to just play once and then stop. We want it to continue playing. So this is a little trick that we can have. But unfortunately, this is not all. We have to, in fact, go to main and bring in a new dependency called DJ system desk. And this is a system descriptor as well, just like we saw before. And this is what we'll call .next when the cycle detects that the track has finished. What do I mean by that? Let's just implement it, and I think it'll become clear. So right below our audio bundle, we will add the following. And this is something new. We haven't done it before. But remember how the input bundle gives us the input system? Well, the audio bundle gives us something like that too. And remember when we talked about descriptors and that every now and then you have to implement your own to manage resources like you want them to be managed? Well, that's what's happening here. We're adding the system descriptor provided by Amethyst that allows us to call this next. right? So if you've implemented any sort of iterator, I think this sort of pattern will look familiar to you. So yeah, closure, music, music next, and then it will always be iterating over that one track inside the array. This is we're giving it the name of DJ system, and it has no dependencies. Alright, now that aside, going back to audio, we just then add the sounds, which is pretty much the same idea, right? Load audio track. We're putting music inside of this music struct, sounds inside of the sound struct, and then returning them inside of this tuple. Okay. Great. Now let's go to our Pikachu volleyball, and as we predicted, we'll add our initialization onto the onStart. So in here, we will bring the audio crate, and here we'll say initialize audio, passing in the world. Okay. Now, let's run cargo run. Let's see what happens. Prepare your ears. And oh, we got an error. Okay. Well, I guess there isn't a get muted. Alright, so this is in our audio. Wait, this is UI text. What? Oh, this is probably just something I did accidentally. Oh, G muted. Winner, line 31, column 49. Line 31. No, I should read cargo messages. There we go. Okay, hopefully that fixes our error. Not sure why that was even there. But yeah, I'll be right back. And voila! Let there be music! Okay, so great. Let me close this. Our background music is working. All we're missing is the sound effects. Right, so let's go back to audio.rs. Close this, minimize this. And so what we want to do now is we want to create helper functions to give access to winner.rs. Okay, let's rephrase that. We want to create helper functions that we can just call in, well, actually not winner.rs. We want to call in bounce.rs whenever we reach a certain condition, right? So if pointing a rectangle, play Pika? Yeah, play the Pika sound. Right, so to do that, we will implement these two functions. Alright, so play bounce. As I mentioned before, we're pretty much just doing the rusty null checks to make sure that we have audio output, and next to get the source, getting the file right from the source handle. Okay. Once we have this, you see that we're playing at 100% sound, so that it goes over the music, right? Now, let's go to bounce, and we will need to add a couple of imports. Hopefully this is clear. I'm hoping I didn't skip over too much here, but if I did, again, ask me questions. I am happy to respond. We'll bring in these two. Actually, we shouldn't need DREF, I think. And audio. Okay, this is just the sounds that we have. Great. Now from Amethyst, we'll be bringing in a couple of imports as well, such as assets, asset storage, no formatter. Wow, Rust Analyzer really isn't working. That's fine. And next up, having this, let's add to our system data the following. I'm so used to formatting. Alright, that's okay. So these three are the ones from the sound, right? We want to give read access to our asset storage. We want to give read expect access to sounds, and then an option output. It's a bit odd, but it's not like we have access to the items in the struct sounds in audio.rs. Do you know what I mean? Like in here, in audio.rs, why are we passing in sounds, right? Why aren't we just like playing the sound? And that's because the world has access to those resources, but audio itself doesn't, right? So if things look odd, that's why. Hopefully that's a good explanation. But anyway, we have these new system data components. So in here, we'll just add these parameters: storage, sounds, and audio output. And drum roll, we're almost there. We'll play the score whenever we hit the ground, right? So that's the first one. Let's play the score before we change the velocity. So play score. We're providing sound, right? Sounds, storage, which is this one, and audio output, which is this one. Hopefully these parameters make sense. You can sort of match them with audio.rs, right? So the storage that we have is from the actual file, right, off of the path. The sounds is, well, this is just the sounds, right? The sound struct that we had. And lastly, this is the audio output, which looks complicated, but oh, is that where we need the deref? I think we do need deref in the end. My bad. Anyway, there we go. Alright. With that, let's just bring in the sound for when we bounce. Which will be in here. Right, that's when we hit our character. Again, let's just bring it on top of these guys. Great. As you can see on my clock, it is midnight, past midnight. So I hope that I'm not rushing over things. I would hate for some of these concepts to go sort of poorly explained. But, so yeah, again, bombard me with questions in the comments if you have them. And if you made it this far, congrats. Anyway, let's open the console, do a cargo run, and no errors. Right, I'll see you in a sec. Alright, it is a bit loud. Let me lower my volume. You can see the bounce sound is working. Now let's try and get Pikachu to hit the ball. Pika! There you go. Great! Things are working, and our game is done. Woo! Alright, we have reached the end of a long journey of Pikachu volleyballing. Anyway, if you've made it this far in the video, thank you so much. I'm glad that you managed to get through sort of my mumbling around and stumbling around and errors and Pikachu nonsense. So yeah, great to have you here. If you've seen any other videos in the channel, you can probably tell that my microphone sound is much better and my camera quality is much better. My camera is even in a different position. It's because I'm using my phone, so I guess a little bit of a better setup. I don't know. I'm little by little figuring out how this whole YouTube thing works and adapting to it as I go. Even in this video, I learned things and adapted little by little, like moving my face up and whatnot. And anyway, there's really no point to this closing statement other than just thanking you and congratulating you to making to the end of the video. That will be it from me, and I will see you around. Bye bye.